These are the different states of a thread during its entire life cycle. Are any of these states familiar to you from your discussion on process? I mean, you have already studied process life cycle. Do they seem familiar to you? If yes, which of the states were present in process life cycle? Or all of these were present in that diagram, process diagram? Please respond. Pratik.
Yes, ma'am.
So, were all of these states were present in process or only some?
Only some, ma'am.
Which were those states?
New,
Okay,
new, dead and block.
okay,
New and dead.
okay. And were there any other states equivalent to this? Running or runnable?
Yes, ma'am. New, ready, running with.
Okay. So you had running and ready, correct? Okay. Now we will discuss each of these states and some functions associated with each of them. So when you want to make a shift from one state to another, you need to have some function. It is similar to your FFL concept. When you move from one state to another state in a finite state machine, you need some input, correct? State, initial state to next state, you should either give 0 or 1. So only on receiving input you will make some transition. Similar to that, in case of a Java thread, some function needs to be invoked on that particular object. Now, as soon as you create a thread, it is said to be in new state. A thread is born. It is in new state. And once you invoke start method, there is a function with this name in Java library. You have a thread object which is referred to by a variable, object reference variable t. And if you want to make it active, you have to invoke start method, t dot start. Then it is said to be in active state. Earlier it is born, it's a newborn thread and it is not yet active, and once you invoke start function, it becomes an active thread. And when I say active, it could be one among these two states. Initially it will be runnable. It is similar to your ready state in process diagram. The thread is ready to execute its code. It is ready to be executed and it is waiting in queue. It is runnable. Initially it will be runnable. It can never be directly running, at least for nanoseconds. For minutest duration it will be runnable, and once it gets CPU core allocated, it reaches running state, and in this phase it will be executing. This state is similar to your process diagram. Runnable is ready, equivalent to ready, and you have running. And once it reaches running, it does not mean it will always remain in running state until it completes its execution. Intermittently, it could also come back to runnable. And this is possible with various functions. This is possible with function yield. When the function yield is invoked on this particular thread object, it comes back to runnable. It relinquishes, it gives away the control of CPU core and comes back to the queue, thread queue. And as long as it is in one of these two states, it is said to be active. And assuming everything works perfectly and there is no other interruptions, at the end of completion, it reaches dead. And before it reaches dead from active state, it has to complete all lines of code defined in its class, that particular thread class. Okay. And in some cases, if not all, a newborn thread could be forcefully made to reach dead state. It has not yet executed. In fact, it has not even entered the queue. And this happens by invoking stop method. If you write t.stop, it becomes dead. Now here is something called as blocked state. This blocked state, it refers to inactive state. When a thread object is in blocked state, it is inactive. It is not carrying out execution of any statement. So, under what circumstances your active thread becomes inactive? There are different possibilities because of which your thread becomes inactive. Reason 1, maybe you have asked the thread to sleep for some amount of time. You will be providing the argument to this function, and this argument will always be in millisecond. If you give 100 milliseconds as the argument to sleep function, then that particular thread object will sleep for 100 milliseconds, and once that time slot 100 milliseconds is over, it again becomes active. And once it becomes active, it will be in runnable state. It waits in the thread queue waiting for the CPU core allocation. Sleep is one possibility, and you could be suspending that thread. You invoke the method suspend, and once you suspend it, it cannot come back to active state until and unless you invoke resume function. If you have written a line t.suspend, if that has to be active again, then you should write t.resume in one of the functions. Somewhere you should be having this resume method on the same object. And third possibility is this particular thread object has been issued wait command. And this wait could be for different reasons. It could be IO wait. Maybe it is waiting for to carry out some IO operation, and that is not yet free. So in that case, it will be in block state, which is very similar to your waiting state. And only when you notify when you notify the particular thread, whatever for whatever reason you were waiting, it has been resolved, it has been granted. Now I am notifying you to come back to active state and carry out with your execution before you complete it, before you reach dead state. Now this dead state can also be reached from blocked. A waiting thread, it is possible. A waiting thread could never come back to active. And the system could issue stop method. The thread is killed right when it is in block state, and at that time also it reaches dead state. So given any thread, it will be in one of these states. You have 5 different states, and now you know the different functions which will make a thread to transition from one state to another state. Okay, so this is about life cycle of a thread. And when asked a question to discuss life cycle of a thread, along with the diagram, you should also mention these functions. So which function is necessary to make a transition, and especially for this transition, active to inactive, you have to write corresponding messages, corresponding functions. For sleep, there is no corresponding function, because the moment that particular time slot is exceeded, it automatically comes back to active. However, for suspend, it is resume, and for wait, it is notify. Until and unless you mention the functions, your life cycle diagram will not be complete. And after the diagram, you should write a brief description about each of the state. And I had told you that the number of cores, it differs from one machine to another machine. Here is one example. This output was taken on the same machine. I mean, this LS CPU was issued on Telnet server. So this you have already seen. So the CPUs are 4 in number, whereas on another machine, observe this line, CPUs are 8 in number. So when you have multiple threads, and depending on the number of CPU cores, your output also changes. I mean, the pattern in which the print messages are displayed on your screen, that is going to differ. When I give any assignment and you execute on your own system, don't compare your output on 2 different machines. I mean, don't compare your print messages and their order with your friend who has executed on a different machine with a different number of CPU cores. The order of print messages and the level of concurrency, it all depends on number of CPU cores, especially when your threads are more than the number of CPU cores. Say you have dual core and you have created 8 threads, and your friend has a machine with 8 cores and 8 threads. the level of concurrency on his system is obviously more because every thread can use one CPU core. Whereas in your case, you have dual core, meaning 2 core and 8 threads. So at any point of time, only 2 threads will be executing. Only when they reach block state, one of the remaining thread will get one CPU. So you cannot compare thread based program just as any other regular program. The order of the messages mentioned in the methods are going to differ based on the number of CPU cores. So this will become evident as you practice such programs on your system. Okay. So this is about